Good morning, everybody. Thanks for coming to the LatinX in Computer Vision Research Workshop today as part of Computer Vision and Pattern Recognition Conference. So first, welcome everybody to the LatinX in Computer Vision Workshop as part of Computer Vision and Pattern Recognition Conference. This conference is organized from LatinX in AI. First, I will give like a general introduction for the organization. LatinX in AI is a non-profit organization, and their mission is create opportunity for LatinX in AI community. Some of the goals are support education and research initiatives, increase representation on global conferences, further career development, nurture a continued relationship between academia, industry, and government, and also help with other things like mentoring platform, provides like some job openings network, and so on. In order to achieve these goals, we have like some resources. One resource is the LatinX member profiles and forum that can be accessed in www.lxai.app. And the idea is that this is a platform that helps to facilitate some communication and resources between members of our community. Sometimes that you need some advice to apply like for a graduate school, PhD, master, or if you are looking for a full-time job, probably you can find some people that can provide you some support and help. Also, other way that we provide the diversity and increase of Latinx representation is via our Latinx Conference Grant Fund. To date, our organization has awarded over 340 conference travel and registration grants to members of our community. These grants mainly work with the following conference with ICML, iClear, NeurIPS, CVPR, NVIDIA GTC. But also in addition to this conference, we also organize some socials of Latinx in AI, and they take place like in conference like LXAI, ACL, EACL, NACO, and so on. So if anyone is interested in helping or organizing this conference, please keep in touch with us. I will share the contact information of the organization at the end of the talk. Also, we'd like to share some statistics about our previous workshops. This is the first time that we organized from CVPR, but there were other organized like for ICML, for NeurIPS. So we'd like to share some statistics. We see that much more of our attendees came from different countries in Latin America, like Peru, Mexico, Brazil, Colombia, Chile, Argentina, Spain, US, and so on. Also, we see that there are like some statistics that we'd like to share. For example, 98 of all attendees connected with other researchers from around the world. Also, 98% learn new research and engineering techniques. 54% received mentoring on their research. 24% received job offers in their field. 2% were connected with PhD opportunities. 5% mentoring others and meet professors from other Latin American universities. Among these attendees, we observed that 72% of the respondents participated for the first time in this kind of conference. So we are trying to promote this participation from Latinx community. Also during these conferences, we have a mentoring program, and we like to gather some statistics about the mentees and also the mentors. In the last NeurIPS 2020, we have 63 mentees matched with 44 mentors. From the mentees, we observe that most of them are like graduate students, early career professionals, undergrad students, senior PhD, or junior PhD. Also, we observe that 70% are male and 30% are female. Then from the part of the mentors, we observe that 40% came from senior industry or academic research, 22% came from faculty member, 20% from faculty member tenure, and 60% from postdoc and early career PhD. Also, we observe we have mentors male 80% and female 20%. Also among these workshops, we like to gather some testimonials of our attendees. So we like to share these ones. For example, Victoria Barin, she mentions the whole program was amazing. You create a unique atmosphere for people to meet and help each other, from students to the most renewed scientists. Also, Ricardo Garrillo mentions, the workshop was an incredible place for networking, sharing ideas and knowledge. It really potentialized the development of AI in our countries. These testimonials really encourage us and motivate us to try to provide much more opportunities for Latinx community, and also trying to have new options or new venues where people can participate. So as in that way, it born like the workshop at CVPR. This is the first time that we're organizing the LatinX computer vision workshop at CVPR this year. And the first thing we like to thank our keynote speakers. We have keynotes like Professor Olga Russakovsky, that she is from the University of Princeton. She will be giving a talk about towards fairness and inclusion in computer vision. Pablo Arbeláez from University of Los Andes with the topic Sinfonía Research Overview. Rubén Villegas from Adobe with the topic Neural Networks for Human Motion Modeling and Character Animation. Also, we'd like to thank Julieta Martinez from a Steel Company with the topic What do large-scale visual search and neural networks compression have in common? And finally, but not least, we'd like to thank Rogerio Ferris from IBM Research with the topic Adaptive Computation for Video Understanding. Thank you very much for your time and your help with during this workshop. Also, as part of the workshop, we have some call for papers. In this year, we have two categories. One is like the full papers and the other are the extended abstract. I think overall we have around more than 60 submissions in total, but we were able only to accept 28 submissions. From these 28 submissions, we have submissions from different places like Mexico, Brazil, Chile, Spain, Colombia, Peru, Germany, United Kingdom, and so on. Thank you very much, all authors, to take the time to prepare their manuscripts, their articles, and also thank you very much for our reviewers that they did a good and incredible work with the reviews. Thank you. Also, we like to thank to the organizing team. Without this team, it won't be possible to do this workshop. First, from the organization and logistics chairs, we like to thank Nils Murrugarra, Guillermo Ochoa. From the sponsors chairs, we like to thank Emanuela Larussi, Christian Canton. From the program chairs, we like to thank Victor Escorcia, Matias Valdenegro. From the presentation chairs, we like to thank Julio Mendoza and Leonardo Nieves. Also from the mentoring chairs, we like to thank Paula Cascante, Pedro Braga, Lourdes Ramirez. From the public relations and website chairs, we like to thank Alejandro Pardo, Luis Santiago, Fabian Cava. And also we'd like to thank our volunteer chair, Cristina Gonzalez. Thank you very much for all of them, and hope we can give like a huge clap to them. Thank you. Then also we'd like to thank our sponsors. We'd like to thank in the Platinum category, Google Research sponsor. Thank you, Google, for helping us in our workshop. Then in the Gold category, we like to thank Facebook. Thank you, Facebook, for your support also. Also in the Gold category, we have Microsoft. Thank you, Microsoft, for all your help. And also in the Gold category, we have Amazon. Thank you, Amazon, for all your support. Then in the Bronze category, we'd like to thank Apple, Salesforce, and Snap. Thank you all for your support. Also in the Bronze category, thank you Adobe and thank you NVIDIA for all your support during the workshop. Thank you all for these sponsors. Without their help, we cannot provide many registration grants for all our attendees, and we provide a great experience for all of us. Thank you very, very much, and also I would ask the audience for a big clap to them. Thank you very much. Then also I'd like to share the general idea of the program. We have the program here in OJ, and also it's in our website. We will have around like 5 keynote speakers. We have oral presentations that came from our call for papers. We have some mentoring hours about the sponsors with interest topics. I remember, I think, academia versus industry, how to apply for some jobs. And I think they will share some insights or some suggestions for everybody. Also, we will have the sponsors booth. So don't hesitate to go there. You can go in lunch or during the poster session. And don't be shy to ask questions or get like some information that may be helpful for your future career. And also, we like to mention that we are going to announce like the best papers in the closing remarks. So please keep tuned about that. Nobody knows the results, so please go and attend there. And also, to end the session today, we will have a networking session. The networking session, I think it's organizing in around like 3 topics, like hangouts, and talking about some infrastructure about computer vision in Latin America, and so on. So please go and attend that at the end of the day. So finally, I would like to share like some support or some resources for the conference. We developed some slides, how to attend CVPR conference. They are on our website, but also if you like, you can use the QR code that is here in the slide. I really hope that everybody has a great conferences, that you learn a lot. And please, if something happens in the middle today, don't hesitate to contact us. We have online support link on the J system, so people can help you. And also you can use our email. And I think we already sent like some useful materials that can help for the day of today. So finally, I would like to share some communication resources if you want to keep in touch with LatinX in AI. We have an account on Twitter, on Facebook, LinkedIn, and also we have our email. Please don't hesitate if you have any questions about our workshops, or probably you want to organize or help in a future workshop in the near future. Thank you very much. And I think, not sure if everybody has any questions. Probably we have 1 or 2 minutes before we start with the next part.
Okay, great. Thank you. I thought it might be good to do just a quick, really quick overview of how to use Oye for those that didn't read the guide and are joining us for the first time on this platform.
Yeah, I think the most simple way that I think we are mainly using today the auditorium room. We have like an initial schedule, and you have like different time slots, and you have the rooms. So basically, you have to click and interact. And during the sessions, the part that most people can interact is via the question and answers. So we can receive questions via the chat that we have there, and also the way that Laura is doing now, that basically somebody can click here on the left side where the people are raising their hands with some question mark. And also you need to disable or enable your microphone in case you need to talk something else more. I think that's most of it. I think then we have some rooms for the mentoring hour. The interaction will be very similar. We have some spots like for the host, and also some spots for the mentors. And also for the poster sessions, we have a similar setup. Like the people will share their posters there, and they also will interact, like doing some questions. Similar setup as here. There will be some spots where you can ask the questions using the form of people raising their hands with a question mark. But also, if you have any issues during the time, please don't hesitate to contact our online help desk that is in our main agenda page. Anyone wants to add something or other questions in the meantime?
Thank you, Nils.
I think if there's no questions, I can leave the time for Juan or for Julio to continue the program.
Yes, can you hear me now?
Yeah,
sorry about that.
Yeah, no problem.
So today I'm going to introduce our first keynote speaker, which is Dr. Olga Russakovsky. She's an assistant professor in the computer science department at Princeton University, where her research is in computer vision, closely integrated with the fields of machine learning, human-computer interaction, and fairness, accountability, and transparency. She's also been awarded the Anita Borg Emerging Leader Abbey Award in honor of Denise Senton in 2020, the CRRA-WP Anita Borg Early Career Award as well 2020. She's been mentioned as in the MIT Technology Review 35 Under 35 Innovator, and she received an award for that in 2017. The Pammy Everinghand Prize in 2016 and Foreign Policy Magazine's 100 Global Leading Global Thinkers Award in 2015. In addition to all her research, she co-founded and continues to serve on the board of directors of AI for All Foundation, which is dedicated to increase diversity and inclusion in artificial intelligence. And lastly, she completed her PhD at Stanford University in 2015 and her postdoctoral fellowship at Carnegie Mellon University in 2017. The title of her presentation is Source Fairness and Inclusion in Computer Vision. So that should be playing anytime soon now. So let's start listening to that now. Thank you.
Hello, everybody. Very excited to be here today to talk to you about fairness and inclusion in computer vision. I am Olga Russakovsky. I run the Princeton Visual AI Lab. This is what we look like these days. This over here is Vikram, who you'll get to meet a little bit later in the talk. So our research is on computer vision, as you might expect, specifically visual recognition and reasoning. So we're trying to build systems that can look at an image or a video and make sense of what's going on in it, reason about all of the constituent components, put it together, perhaps be able to describe it in natural language and so forth. So within perception, we're looking at a wide variety of different tasks. So for example, object detection, spatial relationship recognition, image captioning, action recognition, activity recognition in videos. And for some of these work, we're really diving deeply into the model. So for example, the object detection paper, the action recognition paper we're highlighting here. So these are really modeling focused work. We take a particular well-defined task and are trying to build a better model to solve it. But in some of the other cases, like for example, with the spatial relationship recognition, we realize that the current limitation is really not so much on the algorithm side, but for example, the lack of an available benchmark for it. Similarly, like in the image captioning paper, for example, it's not so much about developing a new model, but for example, thinking about a metric for like a better metric for measuring accuracy or sort of how well an image captioning system is performing. And this brings me to the bigger point that when we're talking about an AI vision system and a visual recognition system, there is a lot of interesting work to be done on the algorithmic side, but there's also a lot more than that. Even, thinking about the task, like this is part of the beauty of applied machine learning, is that we get to think about, so what is really the downstream applications? What do we really want these systems to be doing? As we move from tasks like image classification, where, for example, the metric is, sort of more clear, perhaps, arguably, okay, you're just trying to measure accuracy in this one of K classification task. But now we're thinking about things like image captioning, about more complex video understanding, things like what does it mean when a human action starts and ends in a video, and how do you sort of build models around doing these more complex tasks, and how do you evaluate them? How do you stress test them? How do you collect data for them? And in particular, right, so there's questions around test data and around evaluation. There's also a lot of very interesting research on the training data side, right? So we have to think about the fact that the training data doesn't just fall in our lap. It is collected. It is collected by people who are making decisions about how to go about collecting this data. It is frequently labeled or annotated by people who are sometimes making subjective decisions about what is actually in this image. And again, this is perhaps less obvious when we're talking about tasks like image classification, specifically image classification with, is this a dog or a cat in the image? But even that might be sometimes ambiguous if, for example, the object is very far from you, or very small in the image, maybe blurry. You might not be able to even make that decision with certainty. But as you move to more complex recognition tasks, really the annotations are subjective, or being done by a group of people. So all this brings me again to the kind of zooming out another level. When we think about perception, when we think about visual recognition in our lab, sort of questions of accuracy and efficiency of these systems are just one part of the puzzle. There is a bigger piece of interaction, which is thinking about how do we best learn from and collaborate with people in developing these computer vision systems. And best learn from really means, for example, how do we best utilize available human time or available annotation budget, for example, to get the best possible training data that we can then learn the best possible models from. And the collaboration piece, so that's when we think about some computer vision applications, like you think about autonomous driving, for example, you want the computer vision system to be able to make decisions on its own. You want it to see the environment and be able to act on it without any kind of human intervention. When you think about other applications, for example, so think about even something like image search, right? You have a person who's trying to query a web search engine for a particular image, right? This is more of an interactive process. You can have a computer vision system that sort of proposes some solutions, but then have a human that sort of provides feedback on it. As we think about, household robotics, for example, you have a robot that's assisting you in the home. You want to be able to, have it do some tasks on its own, but some of the computer vision tasks it's doing, actually, it's okay for it to ask you questions or collaborate with you, and this becomes a more effective, more efficient system overall. And so part of the goal of future visual recognition is not just, again, being able to make accurate, efficient predictions on its own, but actually be able to interact or collaborate with people. And finally, zooming out yet another level, there is also this question about how these computer vision systems are affecting people. There's the fairness question. So who's being represented in this data? Who is being represented in the models, and who's being represented in the decision-making of that goes into building these systems? So let me talk first, just very briefly, about the interaction piece, and then we'll dive into fairness more deeply. So for the interaction, the learning from and collaborating with people, so just to highlight, kind of make this more concrete, highlight some of the current work, and all of this, I'm just giving very brief spotlights. And of course, I'm hoping that, the folks listening to this, some of this will strike your interest, and then please, go in and dive deeply into each of these papers, sort of find something that excites you here, hopefully. So with regard to learning from people, so I've already mentioned, right, you're trying to think about how to make best use of human time to get the best possible annotations on your data. So one of our early works in this is from 2016, but I actually really like this paper, and it's quite simple to explain quickly. You're trying to build an image segmentation system. So you're trying to build a computer vision model that is able to do accurate image segmentation. You have a fixed human annotation budget. And the question is, how do you collect the data? So one option is you do full pixel level supervision. So you get a small handful of images, and you get people to really do detailed pixel level outlines of all of the objects in the image that you're then trying to, that you then want your model to be able to segment. This is very expensive per image, but very accurate, very detailed on every image. On the other hand, you could do something like image level annotation. So you get people to annotate just what objects are in every image, but not do the detailed pixel level outlines. So in this way, you can get a lot more images, but with a lot less detail. And, that's a trade-off. You can train a model, in the weakly supervised way using these many, many images, but with image level labels. So it turns out neither of those are optimal, and a much better way of collecting data is what we're calling point level, where we ask the person to say all of the objects that are in the image, but then for every object, provide a single point. You sort of click on this object. If this object is in the image, you click somewhere where, on the object. And this gives this really nice trade-off where it's not much more expensive than image level supervision. So you can get a lot of data this way. But because it provides this spatial grounding, even, very high level of just a single pixel spatial grounding, this actually allows you to train image segmentation models much more effectively from this. And so you end up getting much more accurate models given a fixed human budget. Another way of thinking about collecting human data and the leveraging uncertainty work, this is ICCV last year, sorry, not last year now, 2019. And here we're looking at the fact that, as I mentioned, some tasks are ambiguous. So sometimes you may not, humans may not necessarily agree when they're doing annotations. And it turns out that if you capture that, you can use it, you can design a new loss function for actually leveraging this uncertainty and training better and more robust image classifiers because they sort of understand better the complexities of the data rather than reducing human annotations just to a single majority label on every example. In terms of collaboration with people, so this is learning from, in terms of collaboration with people, so an important line of work here that we're looking at is vision and language. And really, language is the way that humans communicate with each other. And if we're thinking about computer vision systems that are going to collaborate with people, then language is likely to be the primary mode of that collaboration, sort of the easiest way of collaborating. And so we have a line of work around, for example, vision and language navigation, where a human sort of gives a task in natural language around navigating an environment, and an embodied agent is able to reason about that task and reason about the visual input that it's seeing and make decisions about how to navigate this environment. And then in VQA in particular, the visual question answering, we're looking at expanding the space of visual question answering to include both language as well as spatial cues. And so here the kind of key insight of this work is that for visual question answering in the real world, right, if I'm going to ask a computer vision system a particular question about the visual scene that it's looking at, I'm probably not going to ask something like, what color is the shoe of the person on the left, which is kind of how current VQA systems and VQA benchmarks are formulated, because it's just kind of bulky. What I might do instead is ask something like, what color is this shoe? And I would point to the shoe. And so this is a recent work that's up on arXiv around doing this kind of multimodal visual question answering. This is again both a benchmarking work and a modeling. So now coming around to concluding with so we've talked about sort of perception tasks. We've talked about the importance of thinking more broadly about interaction. So this brings us to kind of the core of this talk, which is about fairness. So who is represented in the data? There's been a number of issues that are flagged with computer vision systems as these systems become more complex, more integrated in our world, are making more decisions for us. Starting around 2017, a number of works have been coming out, but also have kind of drawn public attention to fairness issues within computer vision. So for example, computer vision model learns to quote unquote increase attractiveness by manipulating skin color. So this is a photo app that was developed where you upload a photo and it applies a filter to make it more attractive. Now, putting aside the issue of why somebody would want to do that or why this is considered valuable for anybody, I mean, putting that aside, the bigger issue is that it would increase attractiveness. It learned to manipulate skin color in attempting to do that, which really hits on a lot of important and really troubling biases that exist in the world, that exist in the data that was used to train this model, and that became perpetuated in this computer vision application that was developed. Similarly, machines taught by photos learn a sexist view of women, learn to associate gender with particular activities in images. Facial recognition is accurate if you're a white guy. So this is seminal work by Joy Blumweedy and Timmy Gebru, flagging that face recognition technology tends to be more accurate on people of lighter skin than darker skin. There are some excellent books that really dive very deeply into these issues, like Algorithms of Oppression by Safiya Noble, Race After Technology by Ruha Benjamin. And I highly recommend those if you're interested in a really deep look at sort of how these issues come about, how they are perpetuated, what are the downstream impacts of these kinds of biases in technology. But for the purposes of this talk, we'll actually keep this fairly simple. So essentially, we're looking at a cycle where human history, biases, and prejudices are making their way into large-scale data, which then becomes learned by AI models and becomes part of AI decision. And I want to flag here that when I talk about human history and biases making their way into large-scale data, so there are definitely issues with particular demographics being undersampled, underrepresented in the data sets. There's issues with associating particular demographics with sort of particular activities, particular objects, particular tasks, particular scenes. There's also very interesting work and very interesting things going on with geography, with geographic underrepresentation. So I'm going to put up a couple of papers here that may be of interest that flag the fact that current computer vision datasets, even for something innocuous like object recognition, right? You would think that there's no fairness issues in object recognition, but current datasets are not representing the world at large equally. So a lot of the images are pulled, for example, from the US, and essentially no images are pulled from countries in Africa. What this means is that when you're training an object recognition system, it might learn something like for recognizing soap, it learns to recognize US brands of liquid soap and does not recognize bar soap, which is what soap looks like in most of the world. And so this raises, all kinds of questions about even, again, something like where you wouldn't think there would be fairness issues, an object recognition system, but there actually are. And this is part of the thing that we're thinking about, how do you mitigate these kinds of issues that really come from the way that we're collecting the data, the way that we're training these models. What can we do to offer constructive computer vision and machine learning solutions to try to mitigate some of the effects of this cycle? And so there's done a number of works. I'll just, again, highlight some of these here. We've looked at particular data sets like ImageNet, for example, which is one of the most popular visual recognition data sets, try to understand what are the kinds of biases and the kinds of issues that exist in there as a result of data collection processes that were done in an effort to get this large scale data. We've also recently released a tool called Revise for trying to understand and reveal biases in visual data sets and image data sets, because the issue is these data sets are on the scale of millions of images, right? So you can't really look through them manually and predict what kind of biases exist in there, or sort of see the full spectrum of underrepresentation or the full spectrum of different representation of different people in the data set, of different objects in the data set. And so we've built this automatic tool that brings some of these biases to the surface. So this is, it's a series of Python notebooks. You're welcome to download and play around with it. And basically it pulls in an image data set along with whatever annotations are available for it. So if the objects are labeled, it'll pull that in. If there is GPS coordinates that are available for the images, we'll pull that in. Sort of whatever you provide, it will then run extensive analysis, computing statistics of this data set, sort of also running some automatic tools on it, some pre-trained models on it as well, to try to find things like, people of particular genders may be associated, disproportionately with particular objects, maybe different regions of the world are being underrepresented, and it'll sort of provide a way for you to see this. And then you can make decisions about whether these kinds of statistics are what you intended in the data set. So maybe you intended to only collect images from the US, like this is intended and this is fine, but maybe, you did not intend for men to never appear with computers in your images. Maybe, men do actually use computers, so you want to make sure that there are enough images reflecting that. And so this is work, the lead author is Angelina Wang. This was published in ECCV of 2020. And if you're constructing a data set or using a visual data set, we definitely recommend checking out this tool and seeing if it can help you better understand what's in your data. And then on the algorithmic side, we also have a number of work, and Vikram will talk about one of those in a second, around applying different classifier modifications, developing different loss functions, thinking about different ways of training classifiers, given that the data may in fact be imbalanced in some ways. Maybe there is underrepresentation, maybe there is particular correlations in the data that you want to avoid, but it's too difficult to do that through data collection. And so you end up doing this through algorithmic modifications. And then finally, last work that was just accepted to ICML of 2021 on measuring bias amplification in the data. So this is also work led by Angelina, who did the Revise tool. And the core idea here, right, is that biases in data may be actually amplified by the model. So the question is, how do you measure this? And we demonstrate both that some of the existing metrics, in fairness, are not sufficient for measuring this particular phenomenon, bias amplification, and also propose a new metric that that sort of more directly targets this particular phenomenon. And so with that, I will pass it off to Vikram to do a deep dive into a CVPR paper that he was lead author on around developing algorithmic solutions to mitigate fairness.
Thanks for the introduction, Olga. Hi, everyone. I'm Vikram Ramaswamy, and today I'm going to be talking about our work on fair attribute classification through latent space debiasing. This is joint work with Sunny Kim and, of course, with Professor Olga Russakovsky. In current data sets, certain attributes, like gender, tend to be correlated with certain tasks, like cooking or coding. Now, let's say that we want to train a hat classifier. Suppose wearing hats is correlated with gender. In this case, the classifier might pick up on gender cues rather than hat cues. Or similarly, suppose wearing hats is correlated with wearing glasses, as shown in these images. This classifier might only recognize hats in the presence of glasses. What we want, ideally, is a data set that's balanced, wherein these two attributes are independent. However, it can be hard to collect huge amounts of data from the real world that's unbiased. One possible workaround is to use GANs to create a synthetic data set instead, and augment our real images with these synthetic images. As a quick overview, here's how we can use GANs to augment our data. We start with a GAN that's trained on real data. Then we sample random vectors Z in the latent space. Using the generator, we can get an image for each latent vector Z. We can then hallucinate labels for these synthetic images using the model trained on just the real images, and then train an attribute classifier on both the real as well as synthetic images. An interesting observation made by Denton et al. Was that the latent space of a GAN is very structured, and in fact, most semantic attributes are approximately linearly separable in the latent space. This is our first idea. Using a linear SVM classifier, we can learn a hyperplane for glasses. Now, given a latent vector Z, we can compute a vector Z prime that flips the glasses score. This allows us to compute pairs of images, one with glasses and one without. The issue with this, however, is that we have no control on whether or not the image generated from Z prime has a hat. In fact, naively perturbing latent vectors in this way can maintain biases. For example, when adding glasses, we also add a hat, as shown in the image. Since we want to control both the hat as well as the glasses attributes, we can now compute a hyperplane for both the glasses and hats. Given these hyperplanes, we can now compute a hat score as well as a glasses score for every latent vector Z. We can then compute a corresponding Z prime that has a negative of the glasses score but the same hat score. The intuition here is that both Z and Z prime are either wearing hats or not wearing hats, and one of them is wearing glasses. This constructs a balanced synthetic data set. Computing our balanced synthetic data set in this way has many advantages. The first one is that our method can use a single GAN to decorrelate multiple target predict attribute pairs, whereas previous works required one GAN per pair. This method also preserves the intra-class variation of the attribute. Consider an attribute like smiling. This attribute ranges from not smiling to partially smiling to smiling. Since the Z's are chosen at random, a similar distribution exists in the synthetic data set. The final advantage is that the samples are generated specifically to maintain independence between the target and the predict attributes. We'd like to understand how well training with a balanced synthetic data set would do. To do so, we use a CELEBI data set and train attribute classifiers for 26 different target attributes on both the real and the synthetic data. Since we care about fair classification with respect to a predict attribute like gender, we measure the performance of our model using 4 different metrics. The first metric, average precision, is a threshold invariant accuracy metric. We also measure 3 other fairness metrics: difference in the equality of opportunity, bias amplification, and the KL divergence between score distributions. We find that training with such a balanced data set suffers a small loss in average precision, but performs better on all 3 fairness metrics, as shown in this table. Our paper includes other results such as ablation studies of other perturbations, analysis of when our method performs well, and comparisons to prior work. To conclude, we find that our proposed method is effective in reducing bias in visual attribute classifiers. One current limitation is that this method just decorrelates 2 or maybe 3 attributes. It's possible that while doing this decorrelation, we are adding bias along yet another attribute. For future work, this is something we can try to measure and eliminate. If you're interested in this work, here are a few links with some more information. I wanted to end by thanking you all for being here at the LatinX and AI workshop. From experience, I know that research can be isolating, and it's extremely important to find the right communities and the mentors. I'm sure such a workshop goes a long way in helping you all in that regard. Something else that I'd like to stress on is that all of us carry our own internal biases, which are going to be reflected in any model that we design. This is part of the reason why we have such biased systems today. The systems are designed by a very homogeneous group of people, and the models reflect these biases. We need a diverse team of people in order to design systems that work for everyone, and I'm sure all of you will be part of this change. Thank you.
Thanks so much, Vikram. I definitely want to echo everything that he just said. Thank you all for being here today, wherever you come from, whatever your story is, whatever your identity is. We are grateful that we have you in computer vision. We need your voices in trying to build this technology, make sure it is fair, make sure it is inclusive for all. Also want to take a moment to give a huge shout out to the LatinX and AI organization. Thank you for the work you do both in organizing this workshop as well as year round in trying to build a more inclusive community. And finally here, I want to conclude in the last few minutes by telling you about an organization, AI for All. This is a nonprofit that I co-founded a few years ago together with Fei Li, who you hopefully know or at least have heard of, and Rick Sommer, who's an expert in K-12 education. So this is a nonprofit dedicated to increasing diversity and inclusion in AI. And at AI for All, we'd like to say that AI will change the world. It's already changing the world. And the question we ask is, who will change AI? And so our goal is to educate and support a diverse next generation of AI leaders, with the word leaders being particularly important. We want to make sure that power within AI is not concentrated in just a homogeneous group of people, but that the decision makers are really representative of the world at large. We partner with universities and companies to create programs for high school students, some earlier, some middle school, and some a little bit later, early college, that come from diverse backgrounds and try to show them a path within AI. And then our Changemakers and AI alumni community continues to support these students and provide ongoing education and mentorship and community and leadership opportunities for those who choose to stay within AI for as long as they choose to stay with us. And one of my favorite quotes from a former AI for All student is, until this program, I never thought that people who look like me could succeed in computer science and AI. And this is what we're working to change. And so this concludes our talk. We've mentioned, three core building blocks of visual recognition, so perception, interaction, and fairness. I want to give a huge shout out to all of the students who've been involved in this research, of course, first and foremost, Vikram here. And please visit us, visualai.princeton.edu for the lab's website, and then aiforall.org to find out more about AI for All. Thank you very much.
Thank you for that great keynote. And if anybody has a question, don't forget to click on that left panel where you see the person with the hand raised and the question mark, so I can click on you and then you can speak. So feel free to ask some questions or link yourself to ask questions, I guess. And do we have Dr. Russakovsky available? Oh, there we go. Okay, so anybody that wants to ask questions? So I guess I'll start with the first one. You've been working on this field. This field is, relatively new, quote unquote, but it's still, it's progressed so much. What do you think are the most important things that have been, achieved in this, short years? I think you have to unmute yourself. There we go.
Okay, there we go. I think I've been trying to, but every time I do that, I seem to end up back in the audience. So by this field, you mean fairness in
Yes.
the computer vision, right? I think by far the most important thing is the fact that it's becoming part of the conversation generally within computer vision. Like, we have a track at CVPR now that you can submit papers to on fairness specifically. Like, it's becoming part of the conversation. I think there's still sort of some people who agree or disagree with this field, but that's totally fine. I think that's to be expected. But just the fact that it is now commonplace to have these kinds of conversations that is really the biggest accomplishment, I think above all else, because there's no easy solutions, there's no easy answers. This is not something we're going to solve, immediately. But just the fact that kind of everybody is aware and working towards it to bigger or lesser degrees, I think that's really the biggest accomplishment.
Yeah, you're right. I mean, having the conversation, having people, having this in people's heads when they're doing something, it's already progress. So we have a question here from Joao Paulo Lima. Do you think that having more diversity in computer vision jobs will help to have more fairness in computer vision algorithms?
I do, for sure. I do. I think that is it is very clear that more diverse teams lead to more creative solutions and more inclusive solutions. I think having people at the table who are affected by these technologies in many different ways, who come from many different communities, who can imagine the kind of impact these technologies have on everybody, not just on a subset of communities or backgrounds or demographics or experiences. Yes, without a doubt, that will lead to the researchers asking the right questions and providing better and more diverse and more inclusive answers. I'll also say, so I saw Vikram was in the audience. Vikram, do you want to come also join? I know you have a lot of thoughts on this as well. Yeah, there we go. I don't know if you have any responses to this or
Oh yeah, I completely agree with you, Olga. It's sort of like, as long as like everyone has biases, right? Like, so we need a diverse team to actually be able to like head different questions and get better solutions.
Okay, well, thank you for that answer. And we have somebody asking a question that, I mean, a lot of the U.S. research has focused on, on African-American differences. And are you aware, or are you doing any work that it focus more on, Latinx communities in terms of, this bias and the impact?
I think that's an excellent question. So I think so a couple of different answers. So first of all, I think a lot of the research that we do tends to be coming at it from more of like a technical perspective of how do we train a better model for given a particular protected attribute, for example. So that like a lot of the stuff we do actually applies to, it applies to gender, it applies to different race, applies to different skin tone, applies to sort of whatever, applies to different income levels, like whatever the protected attribute is that we are that we're working with, like a lot of the work will apply kind of across all of them. I think the reason why there's been a lot more focus on sort of lighter versus darker skin tone, for example, is because that's a very strong visual signal. And a lot of the research, I think, within computer vision in fairness has been focused on things that are stronger visual, or like gender expression, for example, is a strong visual signal. But I am very excited about this field sort of moving towards like more subtle kinds of research. I think right now we're doing, we're in some ways doing the I don't want to call it low hanging fruit, but in some ways it's like there's particular things that can be done quickly, but then there's much more subtle impacts and subtle differences that I think we're sort of slowly moving towards. I don't know, Vikram, if you have other thoughts.
No, I think. Yeah.
Okay, I have one last question before we keep going on with our program. So do you think that self-supervised learning would help to improve fairness in computer vision, and how could it help to better understand implicit bias in the data?
If we have diverse data sets, then self-supervised learning can help improve. If we have the kinds of data sets that we have right now that have, lack of diversity across many different dimensions, then self-supervised learning is not going to do much for you, right? So if you have a data set of, all people with one particular skin tone, one particular gender, coming from a particular geographic region, like self-supervised learning is not going to help. But generally, I think it help. I think the design of fairness algorithms needs to be done given, kind of in the context of whatever the current like state of the art is with model, in the context of like what are the current systems that people are actually using and how do we make them more fair? And so there's definitely a question about, the kind of biases that can arise in self-supervised learning and how do we help mitigate those. But I don't think that any particular, self-supervised learning or fully supervised learning or weakly supervised learning, whatever, is sort of like the one, answer that will help solve all of these kinds of issues.
Okay, well, we do have one very good question that I do like to ask before we keep going. So this is from Philippe Diaz. Many profit-oriented companies, institutions like Facebook, Google have been defining much of the field in computer vision and AI in general. Do you believe that for prioritizing issues like fairness, we will need some sort of regulation to not only depend on good faith from researchers / institutions involved?
Vikram, do you want to take that one? I think we'll agree on this.
Yeah, I think we do need regulations. It's very easy to just look at accuracy as a benchmark and just push for and use larger and larger models to get better and better accuracy without actually thinking about how exactly the model is going to be used or, trying to ensure that it actually works for everyone. So, yeah.
Oh, thank you. Yeah, larger models or more data.